Welcome to this very brief overview of technical sketching. This presentation is just to outline the essence of sketching as used in the engineering design development process and show you a wide variety of different sketches, both professionally produced and those produced by students studying project or design orientated work. Here's a presentation overview. We commence with an introduction to technical sketching, outlining its purpose, some definitions, and the types of sketch that can be produced. Then we have a section entitled General Sketches. This uses industrial examples to show various sketches and the benefits of the sketching. This highlights the use of annotating sketches, clearly labelling component parts, functionality, etc., and shows how the use of shading can help illustrate sketches. Then the latter part of the presentation, which is the essence of the presentation really, shows an array of past student sketches from various project or design work. These are a series of extracts from students' logbooks, concept selection processes, technical reports, highlighting how sketches have been used and also showing how the students use written descriptive text and also listed the advantages and disadvantages, all of which was endeavouring to communicate the overview of the sketch or the concept to other engineers. And here are the approximate start times related to the various sections contained within the presentation, hopefully to aid your ease of access through the presentation, but please note that these times are rounded to the nearest minute. Technical sketching can essentially be considered as thinking with a pencil. So sketching is a simple technique of pictorial form, often used within the initial stages of the engineering design process to try and help depict components, assemblies, systems, etc., and so a discussion and design development of these various items. Note that sketches do not need to be drawn to scale, although it's strongly suggested they should be drawn proportionally to provide realistic representation, and sketches do not have to be neat or detailed, but they should provide enough information to be informative and understandable. Here's a few illustrations of what's termed freehand sketching. Here, notice that within design environments, sketches that initially produced may need modification due to design changes occurring as the design process evolves. Not much time is usually expended on sketching, but it's important to note that design decision making may often be undertaken on the basis of a sketch, and that can indeed have cost implications for the rest of the project. So it's very important with sketching to ensure that the technical aspects portrayed by the sketch are valid to help underpin the developing design process. Let's consider the purpose of sketching. Firstly, it records ideas. These might be generated by discussions or brainstorming sessions, meetings with clients, etc. Sketches can help develop a number of approaches to solving a particular problem. We're considering the sequences of operations required within various aspects of the design and development process, and it can also trigger ideas through the generation of the sketches. Purpose of sketching continued. Sometimes sketching can identify problems at an early stage within the design and development process. Once the sketch is produced, it can permit rough calculations to be undertaken, for example calculating the volume of a particular object, its geometry, angles, etc., the mass or the weight, strength assessments, etc., etc. Sketches can help estimate the material requirements and also the basic manufacturing processes required to develop the product. And also generically, once drawn, does the sketch look as expected? Sometimes constructing a technical sketch can tend to suggest whether the design is progressing in the right direction. Definitions of sketching. Firstly, pictorial drawing. This is a general term for drawings that show an object in 3 dimensions. Pictorial drawings provide a realistic view and are commonly used within design and engineering. Oblique drawing. An oblique drawing is a type of pictorial drawing where one face of the object is shown in true shape while the other faces are drawn at an angle, usually 45 degrees. Oblique drawings do not preserve the true proportions of depth, making it less realistic, but easier to sketch. Here's a few other definitions associated with technical sketching. Isometric drawing. This is a type of pictorial drawing where all three axes are equally inclined at 120 degrees to each other, as shown here. This method maintains proportionality without perspective distortion. That makes it useful for engineering and technical drawings. So notice in the isometric drawing, axes are offset 30 degrees to the horizontal. So dimension L of our section shown here is at 30 degrees to the horizontal, and dimension W shown here is again at 30 degrees to the horizontal. So that's often termed isometric projection. Notice here I've got a border to the sketch. Sometimes sketches are shown on formal title borders. So to aid professionalism of the drawing, I would encourage you to use title borders where appropriate. Let's consider cabinet projection. This is a type of oblique drawing where the depth W is halved when drawn to make the image look more realistic. This method balances simplicity and accuracy. So notice in our drawing here, dimension L, dimension H are drawn to scale, but dimension W is actually drawn to a length of half W at an angle of 45 to the horizontal. So that's cabinet projection. And cavalier projection, this is another type of oblique drawing. This is where the depth is drawn full scale, not reduced in length like in the previous cabinet projection. However, this approach can make the object look distorted, but it preserves the actual measurements. So again, here's our length and our height, some scale, but this time the depth, dimension W, is drawn the length W at an angle of 45 degrees to the horizontal. This is called cavalier projection. In this presentation, I'm purely going to consider pictorial sketches to portray what sketches look like, the level of detail required, and various annotations and descriptions used to help convey information to other designers and engineers. So let's just consider some general sketches, purely to illustrate the use of technical sketching. So here's some freehand sketching, undertaken both 2D and 3D sketching. I have to apologise, I do not have the reference source for these sketches, cannot give credit where it's due. And some of the sketches relate to older components that are not used so often now. But I'm just trying to convey here the various types of sketching that occurs. Here's a two-dimensional sketch of a thermostat for a car. Here's a car engine ignition, three-dimensional sketch. Here's a moving coil ammeter, voltmeter. There seems to be a three-dimensional isometric sketch. Two-dimensional sketch of a car radiator pressure cap, two-dimensional sketch of a valve rocker system, and another pictorial three-dimensional sketch of a pressure switch. Again, just trying to illustrate how engineers do sketching in 2 and 3 dimensions, and also notice the effect use of shading. This is cross-hatching used to show a section through the component. Here shading is used to give perspective. Sometimes it's referred to as light source shading. Imagine you're shining a light from a particular direction onto the component, give it a three-dimensional perspective. Again, shading shown here, cross-hatching shown here. Here's some more freehand sketches. Again, unfortunately, do not have the reference source to credit the author. This three-dimensional isometric view shows what's termed a bridge and stud. Here's third-angle orthographic projection of a gear bracket, two-dimensional view of a thrust race, two-dimensional view of a flywheel and shaft here, and two-dimensional view of a riveted joint using third-angle projection, it says. Notice how dimensions have been stated to highlight salient characteristics of the designs, and also an annotation has been used to define, in this case, the gear and the bracket, bolt. This all helps with understanding of the technical sketch. This is just some freehand sketching from my engineering logbook when I was an apprentice. When I was on the shop floor, I had to sketch various items. First sketches of a terminal box cover used an electric motor. So this was an aluminium casting, to show the characteristics of the design. On the right hand side shows the core moulding for the casting of an electric motor stator, the casing. This is essentially an exploded view showing how the top and the bottom of the mould are placed together. Here's further freehand sketching from the logbook. Top sketch shows the measurement of a small gearbox. The lower sketch shows how the flanges on the electric motor are being machined. And the right hand side again shows another mould used to generate the casting, the stator shown in the sketch here. So again, illustrations of technical sketching. Sometimes within design environments and design specifications, we're asked to produce more than one sketch of a design. This is a throwback to my degree studies. In my final year, I had to produce a project relating to the design of what's called a feature sign. Sometimes a big structure you see at the front of a business park to try and attract attention. So this was essentially a design project, and as part of the design process I was asked to produce 6 sketches of different feature signs. Consider them as 6 different concepts, and they're outlined here on this slide. Here's an unusual project from many years ago. Abstract shown here, Hornby model train uncoupler. Unusual but very interesting project. Within this work, effectively 5 sketches were produced, 5 different variations of design. In this particular instance, the student chose to draw the sketches using CAD software, so producing 5 isometric sketches of the concept. I also remember when working in the aerospace industry many years ago, a team of engineers were tasked with generating 6 different methods for attaching the vertical stabilizer, the fin shown here, to the fuselage shown here. So basically 6 different forms of attachment were used at these positions here. So they developed 6 different sketches to present to the customer for their further consideration. I'm just going to very briefly show you some past student sketches that were produced for project or design work within college studies, and for each of the 3 concepts produced, a sketch was required. It was annotated, stating the main parts or components and highlighting salient features of the design, after which a written description was included. The description explained the function, purpose, operation of the concept shown in the sketch, highlighting such parameters as materials to be used, manufacturing methods proposed, safety considerations, cost, ease of use, etc. And after the description, the students were asked to state the advantages and the disadvantages of the concept. In other words, outline the pros and cons to the design shown in the sketch. Within the following extracts of the students' work, I will show the sketches, purely trying to show the use of an annotated sketch, and in some instances I will also include the descriptions and the pros and cons for reference. At this stage I'm not particularly concerned about the technical quality of the design work shown. So here's the first illustration from an ex-student. This relates to what's termed a travel plate, which is required for a downhill mountain bike rear suspension system. Basically it was a bracket machined, 3 concepts. Concept 1 shown here, concept 2 shown here, concept 3 shown here, and essentially it's variations on a particular bracket design. Notice again how the students annotated each of the sketches to highlight particular aspects for reference of engineers, lecturers, etc. Here was an electronic wheelbarrow. Initial idea shown here, driving the wheelbarrow using a chain system. Second idea shown here, driving the wheelbarrow using a belt drive system. And the third idea here, using a friction drive system. Very generic sketches, but showing 3 different processes to solve the same problem. Here are 3 sketches associated with a car jack that's powered by compressed air or the exhaust fumes from the engine. Concept 1 shown here, concept 2, concept 3. And again, each of the concepts have been annotated as appropriate to try and portray understanding of the various characteristics of the concept. I added these sketches purely because I think they're quite nice sketches. This is for a GoPed. Concept 1 shown here. Again, annotation used. GoPed concept 2. GoPed concept 3. Again, nice little sketches that are used to try and illustrate the generic overview of the design. Here's concept 1 related to what's termed the equine thermometer project, taking the temperature of a horse. And again, 3 concepts. Concept 1 here. Notice we've not only got annotation of the sketch, trying to convey particular information, but also the advantages, the pros and the disadvantages, the cons are also stated here. Again, added such information helps produce a deeper understanding of the concept and what's being proposed. Equine thermometer, concept 2 shown here. Again, pros and cons listed. And equine thermometer, concept 3. More pros and cons. is the light emitting diode screwdriver. This is a screwdriver that essentially has a light that is to shine along the shaft of the screwdriver, and it's used to light up a darkened terminal that's currently being worked on. So here's concept 1. A description has been used to further enhance the understanding of the sketch shown. The LED screwdriver, concept 2. Again, a description added to help illustrate the concept. And the LED screwdriver, concept 3. Description of concept 3. Here's the door lifter project. The idea here is to be able to lift a door off the floor when you're trying to hang it, secure the hinges in position, etc. So again, 3 concepts used. Concept 1 is the fixed pivot lifter, as it's termed, and a well annotated sketch. And again, the advantages and disadvantages stated. Door lifter project again. Concept 2, adjustable pivot lifter, annotated sketch, advantages and disadvantages stated. Notice these designs are essentially variations on a theme here, with subtle variations between the concept 1 and concept 2. And door lifter project, concept 3, sliding block lifter, with a variation stating the pros and cons. This is an extract from a report related to metallic part pickup tool. Interesting project here. Students develop this on their own experience. They find that when they're working on machinery, they often drop something inside the machine, such as a bolt or a bracket or a screw, and it can be difficult to retrieve. Even when using what's termed a magic wand, it's normally quite difficult to retrieve the items because the magnetic wand is attracted to the side of the machine, makes it difficult to get near the part needed for retrieval. So this was an alternative method of trying to extract bolts, etc. that have been dropped into machinery. Here's concept 1, an annotated sketch of the metallic part pickup tool shown here at the bottom of the slide, and the description for concept 1 shown here, and also for concept 1 of the metallic part pickup tool we have advantages and disadvantages stated. Quite a thorough review of this particular concept, description and pros and cons. Metallic part pickup tool is concept 2. We have our annotated sketch, description of concept 2, and concept 2 continued here, the advantages and the disadvantages of concept 2. And the metallic part pickup tool, concept 3, annotated sketch, description, and the pros and cons. This is an extract from a technical report for what's termed a billet carrier. The billet carrier was designed to help eliminate heavy manual lifting during the production of a particular component, particularly when loading and unloading the billets from the machines. For concept 1, a locking arm sketch, and we have an overview of the concept. There were pros and cons, but I've not included them here. And the billet carrier, concept 2, termed the screw clamp sketch, and an overview of concept 2. And the billet carrier, concept 3, termed the self-closing clamp, came with an overview. This is for a weather station. The weather station is to record data to be used by the meteorological office. Here's concept 1, radio frequency. In this particular system, to have a very brief description of the system, diagrams annotated of the system, and we have the advantages and the disadvantages stated. Our weather station concept 2, GSM solutions termed description, diagram, advantages, disadvantages. And finally weather station concept 3, termed the satellite solution, very brief description, diagram, advantages, disadvantages. And finally, just for fun, here's past student sketches of their lecturer. Not the most flattering sketches, I must say, but hopefully it will give you a bit of a chuckle. Task for the students was, could they sketch me? Here's 3 different sketches from different groups. Here's your sketches. More sketches. sketch of my classroom here, but not very complimentary. Looks like I have a rug on my head here. And the hits keep on coming here. To answer the question here, can they sketch me? I would suggest yes they can, although not in a very flattering way. I hope this brief presentation has been of use to you, and as always, thank you for viewing. Here's the reference source used to help generate this presentation.